Hi, my name is Krister Everly, and this is Lab 2 of Opti 471B called Gaussian Beam Profiling and Propagation. To start this lab, a laser was aligned to a rail in the same method that was used last week, where the laser went through a pinhole at all points on the rail. Next, a microscope was aligned using the same method as last week as well. The alignment of the microscope was confirmed when the crosshairs, the original beam placement, and the expanded beam all overlapped for all points of the microscope on the rail. Once aligned, the microscope was used to measure with precision the placement of the laser and the knife edges. The knife edge was placed on a translation stage and given 50 to 10 micron increments. This gave the integrated power of the beam from which the intensity profile could be derived. That integrated power measurement was done for two different placements on the rail. That way the beam waist could be measured at two different sizes and placements. Next, a 200mm focal length lens was placed on the rail to reconverge the beam at a different spot. The lens was aligned using retroreflections and getting those reflections to align on top of the laser barrel. This configuration caused another beam waist to form after the lens. The approximate placement of that beam waist was found using the same microscope as before and moving that microscope along the rail until a minimum beam waist was found. Then, the same beam profiling experiment that was done before was repeated for this new configuration. The exact knife edge locations were again determined by focusing the microscope on the knife edge surfaces. The two knife edge locations were on either side of the beam waist, so that one was before the beam waist minimum and one was after that minimum. Some data processing still has to be done for the post-lab, but the preliminary results look pretty promising. For both experiments, we saw a pretty smooth integrated beam profile. As expected, the beam profile grew in width the further it got away from the beam waist minimum. When we added in the lens to the system, pretty similar results were seen with a smooth integrated beam profile and two different sized beam waists. And that's the end of the experiment. Now I'm off to do some data processing, but thank you for watching, and I'll see you again next week.